Welcome to Notes 5.6. We're going to be talking about the fundamental theorem of algebra. So what the fundamental theorem of algebra says, if p of x is a polynomial of degree n is greater than or equal to 1 with complex coefficients, then p of x equals 0 has at least one complex solution. Okay, so our example here is if I have this cubic function, it's a polynomial of degree 3. So p of x equals 0 has at least one complex root. Really what you guys need to know, if the degree is 3, it's going to have 3 zeros. If the degree is 20, it's going to have 20 zeros. If the degree is 7, you're going to have 7 zeros. Yes, some of them are going to be imaginary, so they're going to have that complex imaginary portion of it. But it will have that many zeros no matter what, whether it's imaginary or whether they're all real. So if we look at these three different scenarios here, if we look at the first one, x squared minus 4. This one has 2 zeros because it crosses our x-axis in 2 spots. These are real, so this guy has 2 real zeros. Okay, the next case is it's going to hit and bounce back up. Remember when this happens, when we have this comes down, touches, and then bounces? This has a multiplicity of 2. Okay, so this is a multiplicity of 2, but technically there's only 1 0. There's 1 0 at 1, x equals 1. It has the multiplicity of 2, but the only answer is 1, x equals 1. So this one would have 1 real 0. Again, knowing that it has a multiplicity of 2 though. Okay, and then our third scenario here is it doesn't cross our x-axis at all. So since it doesn't cross our x-axis at all, there is no real solutions, but we still technically have to have 2 answers. So my 2 answers would be 2 imaginary solutions. Okay, just a refresher. Remember, imaginary numbers always come in pairs. There can't be just one imaginary solution. It's impossible. They will always be in pairs. So if I have 2i, I have negative 2i. So they're always going to be the conjugates. If I had negative 4i, then my other one is positive 4i. So they will always come in pairs. That's really important for this lesson for us to understand zeros and finding the zeros. All right, so using the fundamental theorem. So step 1, we're going to write the polynomial in standard form. In other words, we want it to equal 0, and then we want our exponents in decreasing order, so our highest exponent to lowest exponent. Okay, then we're going to find the list of possible rational roots. Remember, that's when we do P over Q. P being your constant, and Q being your leading coefficient. So remember, we're going to take all the factors of P divided by all the factors of Q. That's going to give me the list of possible rational roots. Then we're going to use synthetic division to find the roots. So then it's just kind of guess and check. Synthetically divide until I get a remainder of 0. Once I find that remainder of 0, then I have found a 0 of the function. We're going to continue to factor until we have linear factors, and then we'll use the fundamental theorem to find the remaining roots. So then we will solve them. So here we go, looking at our first one. What are the roots of the equation x to the 4th power plus 2x cubed equals 13x squared minus 10x? So step 1, get this bad boy in standard form. So we're going to have x to the 4th power plus 2x cubed minus 13x squared plus 10x equals 0. Okay, like anything, the first thing you should always check for is there a greatest common factor? And if we look at this, we do have a greatest common factor. There is an x in every single term of this polynomial, which means I can factor out an x. So that's what we're going to do. We're going to factor out an x out of this polynomial. So now we're going to have x cubed plus 2x squared minus 13x plus 10 equals 0. This is where sometimes we forget about this x that we factored out. So right away, right off the bat, this x, we can solve for it, set it equal to 0, so we get x equals 0. This is our first root. This is our first 0. X equals 0 is our first 0. We should have a total of 4 solutions to this because it's a 4th degree polynomial, so I should have 4 solutions, 4 zeros, 4 roots, whatever we want to call it. Okay, so now let's look at what we have left. So we have this x cubed plus 2x squared minus 13x. The first thing I would check, can I factor it by grouping? If I factor it by grouping, I would factor out an x squared out of both of these and have x plus 2. Factor by grouping this one, nothing. They're not going to be the same. Can't factor by grouping. Okay, so now we're in that scenario of, all right, we have to do the possible rational roots. List them out, start testing them until we find one that works. So we're going to do P over Q next. So P over Q. So P is our constant, so we have 10 over 1. So ultimately, we're just going to list out all the factors of 10 because all of them over 1. Remember, you guys need to take the plus or minuses. So factors of 10, plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. So that's a pretty easy one. So I have a total of 8 different possible roots that I need to test. So you just start, like I just always start with 1, and then I go -1, 2, -2. I just go in order, so that's what I'm going to go ahead and do. So remember, we're going to do synthetic division. If I were you, when testing these, I would put pen, like I would make this box in pen, and then I would put your constants, your coefficients in pen as well. So we have 1, 2, -13, 10. I'd put all of this in pen. You can even bring down your 1 and put that all in pen. The reason I put this in pen is because we're going to be testing a whole bunch of different ones. So then with pencil, you'll do the rest of this, and then you can quickly erase right over the whole thing and not have to worry about resetting it up every single time. So we can use this same setup over and over and over again. Okay, so now, like, we'll pretend my pencil is the red, okay? So I'm going to start with 1, so I'm going to test 1. Remember, for this, it's multiplying and adding. You'll multiply these two numbers together, put your answer here, and then add these. Multiply, add, multiply, add, multiply, add. Okay, so we're going to get 1 times 1 is 1. 2 plus 1 is 3. 3 times 1 is 3. Add those together, I get -10. -10 times -10, and look at that. I have a remainder of 0, which tells me 1 is a root. Okay, don't lose it. So then we sometimes get confused and we lose it. So my second answer to this is 1. So far I have 2 answers, 0 and 1. Now we need to go ahead and figure out the other 2, the last 2. Okay, so this answer now is a quadratic, x squared, x constant. So now I have a quadratic, so we're going to go ahead and write that out. And then you guys know a million different ways to solve a quadratic. So we have x squared plus 3x minus 10 equals 0. Check for greatest common factor. There's no greatest common factor. I'm going to see if this guy factors. A times c is -10, adds together to give me b, which is 3. So is there 2 numbers that multiply to give me -10 but add to give me 3? Yes, there is. We could use 5 and -2. Double check it. 5 times -2 is -10. 5 plus -2 is 3. Those work, so this guy can factor, which is great news for us. So we're going to have x plus 5, x minus 2 equals 0. You guys know how to solve these. Set them equal to 0. So x plus 5 equals 0. X minus 2 equals 0. So when I solve this, I get x equals -5. X equals 2. So I found a total of 4 answers, which is how many answers I should have because this is a 4th degree polynomial. So all of my answers, we'll put them all together now. So all of my answers, I like to just list them from smallest to biggest. So I have -5, 0, 1, 2. Okay, so I found my 4 zeros, and that's it. That was the whole process. All right, let's go on to the next page. So now we're going to look at this example 2. So we're kind of looking at the similar situation here. So I have a 4th degree. First thing I'm going to check for is there a greatest common factor? This guy does not have a greatest common factor. I would check, does factor by grouping work? So if I put the first two together, last two together, will they simplify to the same thing? No, they won't. Okay, so we are just stuck doing P over Q. So finding those possible rational roots. So we're going to be P divided by Q, which is 6 and 2. Remember, it doesn't matter if I put -6 because when we list out these factors, we're going to do the positive and negative anyways. Okay, so that's all the factors of 6. So let's go ahead and list out the factors of 6. 1, 2, 3, 6, divided by all the factors of 2. 1 and 2. Okay, so let's list these all out. So you're just going to list them. 1 over 1, 1 over 2, 2 over 1, 2 over 2, 3 over 1, 3 over 2, 6, and yeah. All right, so we're going to have plus or minus 1. We'll have plus or minus 2. We'll have plus or minus 3, plus or minus 6. So I just did all the top ones over 1. Now we're going to do all of those over 2. So we'll get plus or minus 1/2. And then we're going to get 2 over 2, which is 1, which I've already listed. Don't list it again. And then we'll get 3 over 2. And then we'll get 6 over 2, which is 3. We already have 3 written, so don't list that one. So this would be all of my possible rational roots right here. Okay, so same case. We're going to, in pen, we're going to list out those coefficients. We have 2, -3. We need to be careful. There is a missing x squared. So technically there's a 0x squared. You must put that placeholder. So put that 0. And then we have -1, -6. Again, I would do all of this in pen so you guys can quickly erase. All right, so then I just start in order. I start with 1. So I'm going to start with 1. So 2 times 1 is 2. Add those together, I get -1. -1, -1. -1 times 1 is -1. That gives me -2. -2 times... Okay, so this is not going to give me a remainder of 0, so this is a dud. We're going to go ahead and erase it. And remember, it'll be nice if you guys are using that pen. You can just erase right over it. Okay, so now I'm going to try -1. 2 times -1 is -2. Add those together, I get -5. -5 times -1 is +5. Add those together, I get 5. 5 times -1 is -5. I get -6. -6 times -1 is +6. So I get a remainder of 0. All right, beautiful. So I found my first 0. My first 0 is -1. Okay, so this one's a little bit different because now what I'm left with here is a cubic function. A cubic. So this is 2x cubed minus 5x squared plus 5x minus 6. So I still have a cubic function. All right, so with a cubic function, again, I can't just factor it. It's not a quadratic. Our goal is to get this down to a quadratic. So what you guys are ultimately going to do is you're going to do synthetic division again on this. And I'll write this all out. Let's write this all out. So this guy right here is 2x cubed minus 5x squared plus 5x minus 6. So again, we're going to have to do that process over. Notice P and Q are going to be the same. P is 6, Q is 2. That's what we had up here. So we're still using these same possible rational roots. It's kind of good to check here because if you end up getting a smaller list, that can be beneficial than having the longer list. So still check if P over Q gives you a smaller list. Use that smaller list. It will help eliminate some of these ones up here. But in this case, it's the same, so we're just going to start with that. So again, we're going to list these out. And if you guys want, and what I normally do is like, I don't write this. I would just put my box straight off of here and just do a double synthetic. That's totally okay. So for this, we have 2, -5, 5, -6. We'll bring down that 2 first. Okay, we've already tried 1. We tried it up on the top one. So don't try 1 again. We've already done -1. Don't do -1 again. So now we're going to move to 2. So I'm going to go ahead and try 2. 2 times 2 is 4. -5 plus 4 is -1. -2. This will give me +3. 3 times 6 is 6. Which, look at that. We right away found our second 0. So my second 0 is 2. Okay, now we are left with a quadratic, and we know how to solve quadratics. So that's what we're going to do next. We're going to take our quadratic, solve it. So our quadratic is 2x squared minus x plus 3 equals 0. Is there a greatest common factor? No. I always check, can it factor? 2 times 3 is 6, adds to give me -1. So is there anything that would multiply to give me +6 but add to give me -1? No, there is not. So it can't factor. So factoring is not going to work. So now you're either left with splitting the middle, or not splitting the middle, that's factoring. You're either left with completing the square, which I don't like completing the square on this one because we have this 2, so I'd rather not complete the square. So now we have quadratic formula. So we do the quadratic formula. So x equals opposite of b plus or minus square root b squared minus 4ac all over 2a. Okay, start simplifying. I'm going to get x equals 1 plus or minus square root of, that's what, -23 over 4. Okay, simplify your radicals. So some of you guys want to leave it like this. This is not simplified. You are not allowed to have a negative inside of a radical. Okay, so what do you do when we have a negative inside the radical? You pull out a -1, which is really I. So this becomes 1 plus or minus I square root 23 over 4. I always recommend that the I comes in front of the square root because some of you guys will put it at the end and then your radical will cover it, which is incorrect. So bring the I out front, and there we are. That can't simplify, so remember, if you can triangle simplify, it simplifies. Nope, can't do that. So I found my other 2 answers. So let's list out all of our answers. So we're going to get -1. We'll get 2. And then we have 1 plus I root 23 over 4. And then we'll have 1 minus I root 23 over 4. Like so. This was a 4th degree polynomial, and I have 4 roots. Granted, 2 of them are imaginary, but that's okay. Still 4. Okay, so find all the zeros of the function by factoring completely into the product of linear factors. Okay, so this one we're going to just break it all the way down into linear factors. Again, when there's 4 different terms, I always check if factor by grouping can work, and you always check for a greatest common factor. So looking at this first guy, or looking at this one, I can see that an x can come out of all of these. So I'm going to go ahead and factor out that x, and then I'm left with x cubed minus 2x squared minus x plus 2. Okay, check if factor by grouping works. So let's see. You should be able to check quickly in your head. When I simplify both of these, will I end up with an x minus 2? And yes, it will work. Hopefully you guys can see that. So I'm going to go ahead and put parentheses around those. The x, remember, is just going to kind of hang out front, so just kind of let it hang out. So the first factor, or the first grouping, I have x cubed minus 2x squared. I can obviously take out an x squared out of both of those, so we're going to factor out x squared. And then we're going to be left with x minus 2. Second one, Remember, you're going to always want to take out whatever sign this is. If this is a negative, you're going to take that out. So I'm going to factor out technically a -1. So we'll have -1, and then I'll be left with an x minus 2. We know factor by grouping worked is if what's left in the parentheses are identical, then it worked. So now we can factor out an x minus 2 out of both of these terms. So that's what we're going to do next. Again, this other x is just kind of like chilling out front. So we have, I'll keep him in red so we don't lose him. So we have x. Out of the first grouping, I'm going to take out that x minus 2. So then I'll be left with an x squared minus 1. All right, as of right now, this is linear, but this is still quadratic. Hopefully you guys realize this is difference of perfect squares. X squared is a perfect square, 1 is a different square, and it's a minus. So remember when that factors, it goes a plus b, a minus b. So we're going to have x minus 2, x plus 1, and x minus 1. So I have completely factored this into all linear factors, all meaning that they all have an exponent of 1. Now we can easily solve this. So the first x will give me x equals 0. The next one will give me x equals 2. Then I'll have x equals -1 and x equals +1. So again, I like to put my answers in order. We have -1, 0, 1, 2. And beautiful. All right, so without using a calculator, find all the roots of this guy. Oh yeah, this one looks fun. So looking at this one, I have a 4th degree. There's 5 terms, so I can't talk about factor by grouping. Is there a greatest common factor? No, there's not a greatest common factor. So my only option here is finding the rational roots and starting to synthetically divide it. So that's what we're going to do, P over Q. P over Q. My P is 12, my Q is 1, which is lovely when my Q is 1, because now we're just listing out the factors of 12. Listing out the factors of 12, so we would have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. All right, again, I would take out your pen. Put this in pen. So we have 1, 4, 7, 16, 12. Make sure none of those skipped. Nope. The first one will always come down. So I do all of that in pen and then start testing. So we'll start with 1. I just like starting with 1. So 1 times 1 is 1, 5, 5, 12, 12. Okay, automatically you guys should be seeing here, there's no negatives being created, so I'm not gonna eliminate that 12 at the end. So that one's not gonna work. Okay, so now we go and try -1. Okay, so -1 times 1 would give me -1. Add those together, we would get 3, and then we'd get -3, which would give me 4, which would give me -4, which would give me 12, positive 12, and then 12 times a -1 would give me that -12, which gives me 0. All right, so I found my first 0. Don't forget it. Don't lose it. -1 is the first one. And now I'm left with a cubic polynomial. So this is x squared plus 3x, x cubed plus 3x squared plus 4x plus 12. Okay, again, this has 4 terms, so at this moment, I would just kind of check, could factor by grouping work? So is there something I could factor out of these 2 numbers? No. But is there a number I could factor out of these 2 numbers? Yes, I can take a 4 out of both of these, and then I'd be left with 1 and 3, and look, it would be identical. So factor by grouping is going to work for this one, which is great news. So we have x cubed plus 3x squared plus 4x plus 12 we decided factor by grouping will work. Okay, so out of the first grouping, I'm going to go ahead and factor out a x squared, and I'll be left with x plus 3. Second grouping, I'm going to factor out a positive 4, and then I'm left with x plus 3. We know it worked when our parenthesis sets are identical, which they are. So I'm going to factor out an x plus 3 out of both terms, and then I'll be left with that x squared plus 4 equals 0. Okay, now we can go ahead and solve both of these. Notice this is almost like difference of perfect squares, except this is a plus. Don't worry though, 4 is still a perfect square. All you have to do is set this equal to 0, subtract the 4, and you'll have two imaginaries right here. So for the first guy, we're going to get x equals negative 3. Hopefully I don't need to do that math for you. For this one, I'm going to end up getting x squared equals negative 4. Get rid of that square root. Or get rid of the squared, square root both sides. So then we're going to have x equals, don't forget your plus or minus. And then, since it's a negative 4, it's going to be 2i. It's imaginary. So plus or minus 2i. Again, I have a total of 4 zeros, which we should have because this is a 4th degree polynomial. So let's list all those out. So we have negative 3, negative 1, 2i, we'll do negative 2i, and 2i. Okay, again, knowing that those imaginaries always come in pairs. If you ever have an imaginary, it has a pair, it's conjugate. All right, last page. Okay, so it says, I'm not even going to read it. I'm just going to tell you guys what to write down. So go ahead, copy all of this stuff down. This is really important. This will be definitely on your guys' final. So make sure you guys have this. So we're going to have number of complex zeros. We're going to have possible number of real zeros. We're going to have possible number of imaginary zeros. We're going to have possible rational roots. Possible, right? And then we're going to have zeros. All right, so we're going to answer all these questions. Let's star this question. This is a really good question. You will see it pop up again. So star it, highlight it. This is where you're going to want to find a question like this. All right, so possible number of complex zeros. That just means how many zeros should I have? So this is a 4th degree polynomial, so I should have 4 zeros. Okay, so I'm actually going to start with possible number of imaginary zeros. So because imaginary zeros always come in pairs. Imaginary zeros always come in pairs. Imaginary zeros always come in pairs. So I could have 0 of them, right? We could have no imaginaries. All of them are real. Or I could have 2 of them. You can't have 1. You'll never have 1. You'll never have 3. You'll never have 5 because they always come in pairs. So then I could have 2 of them. And then I could have 4 of them. All 4 could be imaginary, possibly. Okay, I'm not going to have 6 of them because the most I'm going to have is 4 because this is a 4th degree polynomial, which means it has a total of 4 zeros. You can't have 6, you can't have 8, you can't have 10. Okay, so now possible real zeros. So this one I go in, so that one was increasing, so this one I go in decreasing order. So I could have 4 possible real zeros. And just keep this together. So if I have 4 real zeros, that means I would have 0 imaginary. Okay? Then I would have possibly 2 real zeros. Again, checking this. If I have 2 real zeros, that means I would have 2 imaginaries. You couldn't say that you have 3 because if you had 3, remember imaginaries come in pairs, so that would give you a total of 5, and you can't have 5 because you can only have 4. Hopefully that made sense. Okay, and then my final one is I could potentially have 0 real ones, and if I had 0 real ones, that means I have 4 imaginary ones. So again, looking at this, I will always have that total of 4, which is the max. Okay, possible rational roots is just your P over Q. So P over Q. My constant is 10. My leading coefficient is 1. So it's all the factors of 10. So we have plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. And now we have to go ahead and find those zeros. So we'll come back and answer that one. All right, so I have a 4th degree polynomial. I can't do factor by grouping. There's not a greatest common factor, so we're doing P over Q, testing out those synthetic division. So we'll do our synthetic division down here. I have 1, -1, -7, 5, 10. First one will always come down, do all of that in pen. Now use pencil. I'm going to start with 1. 1 times 1 is 1. That gives me 0, 0, -7. -7, -2, that's not going to give me a remainder of 0, so 1 does not work. So erase. Now let's try -1. So -1, 1 times -1 is -1, add those together, I get -2, +2. This will give me a -5, +5, 10, -10, and look at that, I get a remainder of 0. So we found our first one, which is -1. All right, again, I recommend at this step, see if factor by grouping works. If it works, great. If it doesn't work, then you do it again. You synthetically divide this answer again by your possible rational roots. So looking at this guy, we're just looking at these two numbers. Nothing can be taken out of these two numbers. But I can take -5 out of both of these. If I take -5, I'd get 1. And if I took out a -5, I'd get -2. So right here, we can see factor by grouping is going to work for us. So that's what we're going to do. So this is x cubed minus 2x squared, minus 5x plus 10. Factor it by grouping, first two together, last two together. Okay, out of the first factor group, I can take out an x squared, and I'll be left with x minus 2. Second factor group, I can take out a -5, and I get x minus 2. We know it works when what's in the parentheses is the same. Factor that out, x minus 2, and I'm left with x squared minus 5, which equals 0. All right, x squared minus 5, can't factor it more, but we can still solve it, no big deal. So when I solve this one, I'm going to get x equals 2. When I solve this one, I'm going to get x squared equals 5. Square root both sides, square root, don't forget your plus or minus. So we're going to get x equals plus or minus root 5. Okay, again, remember radicals always come in pairs as well. Imaginaries and radicals always will be in pairs. So now we can go answer our question, what is all of our zeros? So our zeros would be -1, then we would have 2, negative root 5, and a positive root 5. I have 4 zeros because I have 4 a 4th degree polynomial. Brain doesn't work. All right, so let's scroll down. What I actually want to do for this question is I want to add all these components that we wrote right here. I want to add it to this question as well. So go ahead and let's copy those down, because I think it's really important that you guys understand this. So we're going to do number of complex roots. We'll just answer them as we go. So number of complex roots, this will have 3 roots because it's a 3rd degree polynomial. So then we'll have possible number of real roots, and then possible number of imaginary roots. Okay, again, I recommend starting with the imaginaries. Imaginaries come in pairs, so you could have 0, 2, and then could I have 4 imaginary roots? No, you would not be able to have 4 because the max amount of roots that you're going to have is 3. So you can only have a possibility of 0 imaginaries or 2 imaginaries. Okay, so knowing that, remember these 2 numbers will always have to make 3, these will have to make 3. So then the possible number of real roots is I could have a total of 3. Again, this gives me a total. If I have 3 real roots, then I have 0 imaginary because it gives me a total of 3. And then you're going to subtract 2 from this number. So then I would have 1. Check. This would give me a total of 3 roots. Yes, it would. If I have 1 real one, that means I have to have 2 imaginary ones. Okay, so that's how we would answer that question. Possible rational roots is our next one. Possible rational roots. So for those possible rational roots, that's our P over Q. So we're going to have 8 over 2. So let's list those out. So it'd be all the factors of 8, plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. And then all of these numbers over 2. So then I'd have plus or minus 1/2. Plus or minus 2 over 2, which is 1. I already wrote that one. And then I would have 4 over 2, which is 2. I already have that one. And then I would have 8 over 2, which is 4. So this would be my complete list right here. All right, and then our last one is we'll be writing our zeros once we find them. All right, so let's go ahead and find these zeros. Step 1, is there a greatest common factor? No. Step 2, could I factor by grouping? So let's check it. Out of these 2, I would still be left with a 2 and a -3. Out of these, it would not give me a 2 because 9 cannot go into both of these. So factor by grouping is out. So we're going to do our whole synthetic division process. So again, pen, we have 2, -3, -18, -8. First one always comes down. Start it out. So we're going to start with 1. So I'd get 2, -1, -1, -19. Hopefully right here you realize not going to work. So let's erase it. Okay, then we're going to try -1. So I get -2, -5, +5, and then I would get -13, +13. Nope, not going to work. Doesn't work. So now we just move on to the next one. So now I'm going to go to 2. 2 times 2 is 4. This is going to be 1. This is going to be 2. -16. -16 times 2, that is not going to give me +8, so not going to work. Okay, try the -2. 2 times -2 is -4. That would give me -7. This would give me +14. This would give me a -4. And then I would get a +8. There it is. Found it. Our first zero is -2. All right, now we're left with a quadratic. We know how to solve quadratics. At least we should know how to solve quadratics. So this guy's going to give me a quadratic of 2x squared minus 7x minus 4 equals 0. If it can factor, we should definitely factor it. So let's check it out. A times c is -8, adds to give me -7. So we would have -8, +1. Double check, -8 times +1 is -8. -8 plus +1 is -7. Okay, remember when we have an a value that is not 1, when you write your factors, you're going to put a 2 on both of your factors. This is the shortcut method I use. And then technically there's a 1/2 out front. The 1/2 will always be eliminated, or whatever the fraction is will always be eliminated, so don't really worry about it. So then we have 8 and +1. 1 or both of these will simplify. So looking at my first one, I can factor out a 2 out of both of these. And that's why when I factor out that 2, this 1/2 will cancel out. So this is going to give me an x minus 4. And this one does not simplify, so I have 2x plus 1, which equals 0. So I'm going to get x equals 4 and x equals -1/2. Notice these are both real and they are rational. So these numbers should be a part of our list. And they sure are. 4, 4, -1/2, -1/2. So for instance, if we had found 4 first, that's totally fine. 4 would have worked over here and -1/2 would have worked over here. So list out our zeros here. We have -2, -1/2, and +4. All right, and that's going to go ahead and conclude our lesson for today. I hope you guys all have a beautiful day.